Welcome to the Aerospace Ambition podcast. I'm Marius, your host, and an engineer passionate about the intersection of sustainable aviation and AI. In this episode, we'll explore how pilots view contrail management. I am thrilled to welcome Jeremy Thomson from BALPA, which is the British Airline Pilot Association. Jeremy graduated in theoretical physics and has held various roles in science communication and renewable energy technologies. In 2012, he began training as a short-haul airline pilot. Jeremy has been an active volunteer representative on several BALPA flight safety groups and founded their environment study group in 2020. Jeremy, welcome to the show.
Oh, hello, Marius. Thank you very much for inviting me.
It's great to have you, Jeremy. And you're living the dream of many people. That is being a pilot and flying aircraft. So since when are you a pilot and which aircraft types do you fly?
I started flying on the line in 2014. In fact, this month is my 10-year anniversary of working as an airline pilot. And I fly the Airbus 320 family. And in fact, everything from the 318 up to the 321.
And when was the first time that you learned about the sustainable aspect of aviation and that you especially learned about persistent warming contrails and the effect on the environment?
I've always been very aware of efforts to reduce the fuel burn in the general operation, but it was about 4 years ago that I started to ask questions at BALPA, that's our professional association, about why we weren't directly tackling this and we didn't have any groups looking at it, especially as I could already see that regulations are on the way and would affect our members. And as these things go, when you start asking awkward questions, people ask you to put the work in. So that's why I was invited to set up the environment study group for BALPA, which I did. And that's become a very active and busy group. And we're very proud to have formed an environmental position, written a long position paper. We think we're the first member association to do so. And then shortly after that, really, that we discovered how important this concept of contrail management is to the environmental impact of aviation, in particular working with a chap called Professor Ian Poll, who is the Professor Emeritus at Cranfield University and a huge advocate for this.
I think it's episode 2 or 3 where he was a guest here. But maybe you can give 1 or 2 sentences of a background about BALPA and what is your angle in the aviation community.
Certainly. BALPA is a slightly unusual association that does 2 things. It is a trade union in the traditional sense, so it's always working to improve terms and conditions and pay and protect members and assist them where necessary. But it's also a professional association, so it looks after things like professional standards, but most importantly, flight safety. And until my group started, really, all the technical groups were looking at different aspects of aviation safety. So we're a slightly unusual group that kind of crosses over between industrial relations and safety, and also looking forward to sustainability for its own sake as well.
And you've basically created a bunch of work for yourself by pointing the organization at that problem of contrail management. But within the broader scheme of sustainability on the flight deck, in the cockpit right now, what are initiatives to promote more sustainable aviation and operations?
Well, there are some things that we are working on. I think most airlines will have an initiative which you could argue is actually to reduce fuel burn rather than because they want to be environmentally friendly, but they often achieve the same ends. And that's things like single engine taxiing, reduced APU usage, flying different cost indexes or altitudes to save a bit of fuel, and just general efficiency improvements and awareness about the way you can deploy the fuel that you've loaded more effectively.
One thing is, of course, the awareness, and one thing is to, reduce fuel burn. There's a direct correlation with the emissions. But are pilots also incentivized to do that? How is their behavior actively being nudged towards that?
I think it depends. It varies airline to airline. I think some airlines are more interested and make more effort to incentivize the pilots. I don't think anyone's gone as far as financial incentives, but I am aware that there are products being developed that allow pilots to see their own performance and see where they could have done better. And some quite clever psychological work's gone into some of these that just help to understand and motivate people to fly more efficiently.
Can you give an example, a concrete example of what this would look like before and after?
Yeah, certainly. So one company that we've worked with before is called Signal, and they produce a dashboard that, in a very secure way, takes data from your flights via the airline, anonymizes them, and produces reports that are tailored to the individual. And it can do things like suggest goals that you can work towards and show you how you're performing against those goals. It's able to use those, whether you've achieved those goals, to, for example, make charitable donations, which is quite a strong incentive. And I think it's quite a clever and flexible piece of software. I'm sure other programs like this exist as well, but we just happen to have worked with Signal, mostly on the data confidentiality aspect, which I'm happy to say we're now perfectly happy with as a union.
That's great to hear that there are companies solving the problems in such a way. And one of the problems may also be associated with taxiing. What's wrong with taxiing?
Fundamentally, aircraft are pretty efficient in the air and absolutely hopeless on the ground. I mean, using the jet engines to move yourself around the airport is kind of crazy, but that's how we do it. And if it's a busy airport, you can often be taxiing for 15 or 20 minutes. So the thinking now is you start the fewest engines that you can in order to maneuver safely, and then you only start the remaining engines when you have, 5 or 6 minutes before departure. That's the ideal. It's actually quite hard to implement because the only people who know the exact departure times are the tower controllers, and they're constantly changing and flexing their plan. So there's a bit of guesswork involved. And some aircraft type are easier to do reduced engine taxi on than others. So it's a bit of a mixed implementation, but it's definitely catching on. Taxiing back in after landing is much simpler because there's none of this timing issue. So that's much more widespread, I think, to close down at least one engine after landing.
And is that closing down of one engine after landing something that is widely adopted already, or is it more an experimental kind of thing? I mean, it has to have some technical validation, right, to make sure that the systems still work properly, even if one engine is shut down.
Oh, absolutely. The aircraft has to be certified to do that, and the 320 family certainly can be. And I think most operators in Europe on the 320 are doing single engine taxi in, and most are doing single engine taxi out as well. I can't really speak for other aircraft type.
And do you see any opportunities in that taxiing domain for the future? Anything that is being worked on? I mean, there has been discussions about electric autonomous ground vehicles, for example, the pushbacks, maybe extending their pushback, towards closer to the takeoff position. Do you see any promises there?
Well, we'd love to be able to self-maneuver without starting engines. That's not likely in the immediate future. I think the biggest gains in that area would be better adoption by the long-haul aircraft types of reduced engine taxi. In my experience, that happens less on the larger aircraft, and of course the savings are greater there. So that's the area I think should be looked at next.
So now that we've spoken about, the optimization with regards to more climate-friendly aviation on the ground, let's look at some opportunities which we have in the air. Within BALPA, one topic that you've been driving is Contrail Management. And this leads me to the question, are pilots right now, in 2024 being educated on the problem of contrails and persistent warming contrails?
No, and in a sense, that's too early to do that. I think contrail management is super important. It's our biggest opportunity to reduce our climate impact as an industry, and it's really important that progress is made. But that has to come from research, it has to come from the air navigation service providers, and it has to come from the operators. And that really has got to come ahead of flight crew engagement. The flight crew essentially will do what they've been asked and trained to do, but that all has to be put in place first. Of course, I don't object to educating flight crew about the problem, and that does need to happen at some point, but at the moment awareness is not very widespread, I would say.
But then again, within BALPA, that's one of the benefits of such an organization is that you do that, right? So you do educate your members on this. And how do you explain the current status of certainty to your members?
This is an argument that's going on all the time. Is there enough scientific certainty to start actually implementing contrail management? And we think there is. One of the most important studies done on this by David Lee and colleagues has got very large errors on the potential strength of this effect. And unfortunately, this kind of has set a bit of a precedent for people saying, look at the size of that uncertainty, we can't do anything yet. But actually, there's been 5 or 6 more studies that have tried to estimate the strength of the radiative forcing in different ways. And very pleasingly, they do all agree. To some extent, the error bars overlap and they're starting to converge on a much more certain picture, which seems to be that the contrails are causing about the same amount of warming as the CO2. So this argument that we need more data, we need more certainty, may have been true a year or two ago, but I think we actually have that data now, and we have enough certainty to move ahead, and certainly into large-scale operational trials now.
And the question is always, what is uncertainty, right? And uncertainty can only be linked to the impact that you have. And the impact could be, of course, positive, but it could also be negative. And the negative impact is the fuel penalty. So that's one of the main arguments that people mention against acting right now. But what is actually the fuel penalty? The fuel penalty is something, it's basically a difference to a baseline. It's a difference against an optimum flight route. What should actually be the optimum flight route realistically that we should compare the deviation against? So what should be our baseline?
That's a really good question. And I think it speaks to a misconception that many people have. And I don't mean this as a criticism, but researchers as well have, that airlines are already flying as efficiently as they can. And that is simply not true. Airlines as a whole will do what their shareholders want them to do and maximise profits. So what they actually do is flight plan for minimum cost. And that is not the same thing as flight plan for minimum fuel. There can be quite a significant difference there, perhaps up to 10% or even more on some flights, where they might be doing things like flying at a lower altitude to avoid delays. They might be tankering fuel to save money on the return flight, or they might be avoiding more expensive airspace. Now, all those things actually increase fuel burn quite significantly. And we're talking about an order of magnitude difference between the potential saving from the way the operation is conducted now to an ideal operation compared to the cost of doing the contrail management, which I've seen various studies estimate anything between essentially nothing and about 0.5% across the fleet. So it's really small.
From your operational point of view, from your experience, could you maybe give some examples where inefficiency occur during flight anyways, even without any contrail management, which create maybe even a much, much larger fuel penalty?
Yes, of course. Flights are quite dynamic things. Every day is different. So even though the flight plan has been filed and approved, you may find you have delays that weren't expected. You may find you have congestion and have to take a lower altitude. There may be storms that you have to deviate around. There could be a problem at your destination airport that leads to airborne holding. 5-10 minutes is completely routine at Heathrow, but we usually have enough fuel to hold for 20 minutes. And then sometimes you have to divert. So there's all sorts of reasons why you will actually burn more fuel than you expected on the flight plan.
Okay, so now that we understand that from your point of view, there is enough certainty to act, and we should also, when doing the certainty calculations and the benefit calculations, we should pick the right baseline. The question is, with regards to scalability, in the mid and long term, how should it be done? And there are two major approaches, I'd say, and one is a centralized approach where the air traffic management guides all the deviations, and the decentralized approach where each operator, airline or pilot takes the decision and then individually requests a diversion. I'm sure you also speak with air traffic management or ATC controllers. How does such a conversation go?
Well, we are indeed talking to NATS, which is the air traffic control for the UK and also the North Atlantic up to 30 degrees. So it's a very large area. And although it's early days, they are positive about it, and we are working towards the design of quite a large-scale trial, which will probably be in that North Atlantic airspace. To go back to your thrust of your main question, though, I think in an ideal world, the contrail management would be implemented by the air traffic controllers. But that's a long way ahead and requires a lot of knowledge and coordination. If we wait for that, that could take 5 to 10 years at least. That's a huge missed opportunity. It's actually much easier at the moment for the operators to implement the contrail management using tools that are already available. And yes, they will need to be improved over time, but that's an iterative process. But they're in a much better position to start doing this, to gain experience and to validate the concept now. And then as that becomes more widespread, it's natural for that responsibility to transition to the air traffic control systems.
Since you mentioned nuts, we had Sean Andrews on the podcast as well. And she also pointed out the opportunities in the North Atlantic area, which makes me think in some areas, the air traffic control is not, purely voice, but it can also be managed, let's say, the communication through an iPad, in a digital way. Are there certain areas which, would make the contrail management more feasible or where it's more scalable already?
Yes, the reason we talk about the North Atlantic traffic is it is a perfect test bed for contrail management. The traffic is mostly returning west to east at night, and as you know, contrail management is much more important at night. It's all flight planned on fixed routes, and now we have the technology it used to be all done by mostly flown on the pre-planned route, and then you could use high-frequency radio to try and make changes that were very difficult. And that resulted in large separation between the aircraft and usually them not being able to deviate from the plan. And now we have satellite communication and a system called CBDLC, which enables the pilots to interact with the controllers almost in real time and request changes and deviations. And also the controllers could always know exactly where the aircraft are. Those separation criteria are much more relaxed. And generally, there's the freedom now to allow changes and deviations during the flight as well as at the pre-planning stage.
Right. Is this something which is going to improve even further? Is there much digitalization going to be expected for the future, which could then create a better basis for scalable contrail management?
I think the improvements will happen with the flight planning systems and the contrail management being built into them. And we do need really good weather forecasting and right up to the last minute when the flight plan is issued for the best results. I don't think the communication system between the pilot and controller during the flight will change, but it's already okay. And the other thing I think is coming, and in fact I've seen some really good test software already, is better tools for the flight crew to use during the flight to visualize how they can improve the efficiency of their flight and also to implement the contrail management in a dynamic way. So ideally with these satellite links, you'll be able to refresh the weather data during the flight and it'll be constantly recalculating the best route to take and the areas to avoid. And I think that will make a huge difference.
So what you're pointing at is an interesting aspect of contrail management as well, because you could do it in a pre-tactical manner using the flight dispatcher, or you could then do it during the flight when you do tactical deviations. Now, you'd be affected by the second kind of approach, right? How do you view these two approaches?
Simple. We need to do both. You do your best attempt at the flight planning stage. You know things might change, especially on long flights. So you need some way of getting data into the flight deck so you can constantly recalculate that. And those tools already exist. We work with a company called Flight Keys that have provided exactly this. And there's some very impressive software for the flight crew to use. So, yeah, there's no reason not to do both at the same time. And I don't think there's any other solution that's going to be effective. I mean, contrail management isn't easy in the sense that you need such accurate weather forecasting and it changes all the time. And I should also add it needs to be validated after the flight to check you're doing the right thing and it had the effects that you hoped, which is itself quite difficult.
Right, and a shout out to Alejandra Martin Frias from Flight Keys, who was also a guest on this show. And another shout out that I should give is to one of the previous guests from Google. It was Sebnem Ercan, who basically presented what Google is doing, in the space. And since she was a previous guest, she had a question which she passed on to you. And essentially the question which she passed on to you was, what could Google within their work do to make life easier in the context of contrail management, to make life easier for you as a pilot? Is there anything they could do? It's a free wish now.
That's a really difficult one. In terms of day-to-day operating flight crew, I don't know if they could directly assist. I think where Google's real strength is this validation work. So their use of AI to analyze satellite data will be a really powerful tool to make sure that the contrail management efforts we're making actually work, or if they don't work, why they don't work. Because we need a system where we can constantly adapt and improve to get the best out of this.
So there is a potential, you would say, in further developing what's called the electronic flight bag?
Yes, absolutely.
To increase the visualization and the understanding of the current situation, to enable the pilots to more dynamically adapt to changing weather conditions, for example?
Yes, and it's a win-win because it's not just contrails we're talking about, but all sorts of weather, turbulence, storms, etc., wind changes. It's all valuable data for the flight crew to operate the flight as best they can. So it helps in both ways, yeah.
Now I'm going to shoot a very quick question, but I can't skip this one. How do you feel about lateral deviations compared to vertical deviations?
My understanding is normally vertical deviations are the best way to avoid supersaturated areas, simply because they're not terribly deep, or they can be quite laterally widespread. But we do routinely already avoid bad weather and thunderstorms laterally, so it's not new to us, and I don't think it'll be a huge problem. Also, you'd be surprised how few miles even quite a large deviation adds to your total flight. You might fly around, you might take a 20 or 30 degree heading deviation, fly it for 60 or 100 miles, and it will add 1 minute to your flight. So it's quite achievable.
So to conclude this episode, from a pilot point of view, what can pilots do? How can they encourage their airlines to explore contrail management more? Or even start exploring contrail management?
The knowledge is not very widespread. I'd say there's some fantastic resources online. You can read about it. It's really exciting. And I can't think of any example in any other industry where they have an opportunity to potentially halve their global warming effect so cheaply and easily. It's a huge opportunity. And I would encourage all crew to read about it and contact their manager and say, guys, why are you not doing this already? This needs to happen.
So this is a clear call to action for all the pilots listening to this. And my last question is with regard to the regulatory framework. So where do we stand here from your point of view? Are we on a good path?
There's not much regulatory work in place regarding contrails at the moment. They are in the part of the EU Fit for 55 requirements will mean airlines have to report their non-CO2 effects, which of course this is one, and start to quantify them. And I imagine that is leading up to potential new legislation in the future. I would really sincerely hope that operators don't wait to be forced to start doing contrail management, because as I say, it's not expensive, it's not difficult, and they could really start doing it quite soon. I think the passengers, if the ones that are interested, would appreciate that, and certainly their business customers who are asking some increasingly difficult questions of the airlines they use would be very pleased if that happened.
And in order for that to happen, you mentioned it already, we have to improve the weather forecasting as well. And in our next episode, this is what we're going to discuss in depth, because we have two guests from the German Weather Service, DWD, and that is Dr. Carmen Emmel and Dr. Björn Rüdiger Beckmann. And you have the chance to pass on any kind of question to them.
Oh, actually, I'd be interested. As I say, we do desperately need the most accurate weather data we can get to pinpoint these supersaturated areas. But actually, I'd like to ask them what the airlines can offer in terms of data back to the researchers, in terms of perhaps humidity sensing on the aircraft. We already routinely produce and transmit temperature wind data. So I wondered if the routine air traffic itself could help with their models and help to produce more accurate forecasting for this purpose, and how that should be implemented.
Consider it done. I will place the question. And thanks a lot for being guest on this podcast.
No, it's my absolute pleasure. Thank you for inviting me.
Thanks, and speak soon.
Goodbye.
Bye-bye.